Alright guys, so what I have here is an original IREM Kung Fu Master board. I was showing you these when I was doing the bootleg one, fixing the bootleg one. And this one is interesting actually, I won't show you right now, but it has an extra board to replace a custom chip. But this board has a slight problem, so I'm just going to start this. And what the problem is that the sprites aren't displayed. The sprites aren't displaying properly, and I have the schematics for these, and I'm doing this after the fact, so I've actually fixed the board, well, fixed some of the issues of the board. And what I discovered was that this guy here, which I've already replaced, well, not quite, this is the original chip that I've put back in, and I've replaced it with a better one, but I'll just show you what happened. So I identified that this guy actually wasn't receiving a signal in here, and this fellow actually just receives a number signal and decides which one he's going to display at one point. And essentially what happens is you have your sprite fields and the background fields, and maybe sometimes the characters, as indeed the numbers and letters displayed on a different field. So it'll actually switch between the two, all of these, and pull out one of them a signal. And essentially this one wasn't receiving a signal at well, one of these anyway. I traced it, and I traced it back, so it's probably 6 or 11. I think it was 11. Traced it back to this chip at 1B, which was this one. And the output 7 was actually floating as well. So what I did is I replaced it with I put a socket, and then replaced the chip with this guy right here. Actually, I need to put it in the okay. And sprites should be displayed properly. Now, they're not quite, but they're actually getting displayed. So what's happening here is we have so sprites aren't all in one cell, they're actually dispatched across different RAMs here, and so I tried to trace where this was coming from, and from the schematics I did find that it was 5K. I'm trying to locate 5K again, so there was 5K here, but what I found was that I've made myself a small rig because this board didn't have any input, so I just got myself a 5 and ground volt, and I found that this chip here at 5, so 5K, so we count the 5, and then the letters are here, so 5K brings us to this chip here, this guy here, and this is a Fujitsu chip. They're actually known for failing very, very easily. What this is here, so this actually happened because I was just checking input and outputs, and I saw that this was a Fujitsu chip, so I decided to check the input. So this is an OR gate, and what we have here was this. We have this pin floating low. This is 11, and 11 OR gate. Sorry, I'll show you the schematics. So the pin 11 on an OR gate here depends on the input of 12 and 13. So for 11 to be stuck low, we'd have to have either both of them low or both of them high. This is an exclusive OR gate, sorry. So we have a low here, and if I check 12, it's actually toggling, and 13 is actually toggling even faster. It's toggling so fast that that yellow light isn't even we can't even see it moving. So that tells me one thing. It tells me that that this chip is most likely defect. So I'll show you what happens when I piggyback a newer, better chip. So what I've done here is I've just put in another OR gate, LS86. It's an exclusive OR gate, and it's called piggybacking. Sorry, you're literally sitting the chip on top of the other ones. The reasoning is that if one of the pin is stuck low and should be high at some spot, sometimes the high will actually override the low. So if it toggles, it'll actually toggle it high at the right time. It won't toggle it low because it's low already, but at least we have that. So essentially, this one will override the high. It doesn't always work. So if the other chip is actually stuck high, having a better chip won't change anything, because low will not actually override high. That's the idea behind it. That's my understanding of it anyway. If I'm wrong, correct me, but that's the way I understood this. But anyway, let's fire it up and see what happens. And there you go, the sprites are being displayed, and yeah. So you'll notice something, the death sound here isn't playing. So we have the other sounds, but the death sound isn't playing. There's a reason for that. It's actually the same reason that I saw in the other video, and I'm gonna grab one of the other broken board for this. And the reason the sound isn't playing is that, so the music is handled by this chip, and then these chips, sorry, these are Yamaha 2149, these two. And these two guys here are Akai M5205. These are speech synthesizers. And so let's credit. You heard the wada sound. So that's handled by one of the chip, and some of the other. Obviously this one working. So this is this chip here is handling your character sound, and this one here is handling the death sounds and the laughs of the enemies. So this chip is actually faulty, so we're going to replace that as well. So little update. So now that I know that this board stack is working, I'm going to use it to fix the other board, and I'm going to use it I'll just show you it's working, but I'm going to use this so that one board at a time I'm going to swap the boards from the other board. So that's what I've done here already. I've taken the G board. So this it's the M62 system by IRM, and there's a stack of 3 boards. So there's the A board, you can see here, the B board, and the G board. And so what I've done, essentially, I've just put the other one on top of it, and then I changed it to Fujitsu chips that were here, these guys here, that are known to fail. Just because I was in the process of swapping the RAM. So I was getting a lot of pixel issues, errors, and essentially I just piggybacked a new RAM on top of this one, and it fixed the problem. So what I've done is I've actually socketed the 2 RAMs. This is the old RAM that was here already, but I just put it in a socket while I was at it, and then socketed a new RAM here. This is a 10. So these are 2016 AP12 that were there, and the 2016 BP 10 can be substituted for these. So, and they're slightly faster. So that's what I've done, and it's fixed the graphic issue. I can try and show you maybe what the issue was. See if I can socket the RAM into this one. So there you go, this was the error I was getting, and I identified that this was the RAM. And what I just did is I just piggybacked the RAM on top of this one. Let's see if I can do that and fix the problem. Maybe not on this one. Yeah, it's kind of hard. But I could see the pattern being altered, and yeah, there you go. And this isn't great. And putting the RAM fixed, a new RAM fixed the issue. So there you go. I'm going to put it back, and then the next thing I'll need to do after that is change. So this is the A board, and then the B board is below. So I'm going to take the B board from this one and try and see if it has any issues and fix that. And then when I have the C board, sorry, the B board and the G board all fixed, I am going to start looking at this one, because I think this guy is not booting. So I'm going to have to replace the RAMs, obviously, and and see if the ZSG is fried or there's any other issue on this one. But I'm gonna fix the two of them in one go, really, in one video. Okay, so on this second board, I've done a number of things already. So this is the CPU board, this is a graphics board, and I have already fixed the character board. But here, what I decided to do is I socketed a number of ICs already. So all these were Fujitsu ICs, and I mentioned that these are a common point of failure. There's actually one here that I missed. What is it? Can't really read it. I might do that as well. There's no point leaving them, and while you're changing them, this is a 368 LS368. I think I have some of these as well, so I might change it. But you know, there's no point leaving them. If you're changing one, you might as well change them all, because it's just a matter of time till they fail. So I changed 1, 2, 3, 4, 5. The issue here was that the board wasn't starting. So I had a quick look. There's actually a pin here, which is the read enable, that was out of the socket. So I straightened that, put that back in the socket. These are all the multiplexers. Are they multiplexers? 367, can't remember. But the dispatch, they're part of the, as far as I understand, they're part of the address decoding circuit. So if these fail, essentially your board is dead, which was the case here. I changed this one just for good measure, and I also socketed the RAMs here, and I changed the RAMs. You might as well, these are pretty common, and just might as well put new ones. Now there's one thing here, is that we're missing a few ROMs. So these ROMs here, it's very interesting, these boards. So this is all the Sprite ROMs. So there's different versions. These are the what are they? Are they the 120 RAM? The 128, yeah. They're the 128 K ROMs, or normally on the other board that I have fixed already, they're 64 Ks, just like here. So here, this is the bootleg, but they're all the same ROMs. They're all 64. So the stack is full. Here they're 128, so we only have half of them, which makes sense. And this is verified here with the. I downloaded all the ROM name information. Just made this thing. So on the Kung Fu Master US, which is what I have here, we only have these unique ROMs for the graphics. So indeed, this is verified here. These are all the 16K. And then here we have the full stack. So this is what we have in the bootleg, and the two bootlegs. This is the world version, and this is the two bootlegs available in MAME. So these are all sharing the same ROM. So all the ROMs here are the same. The here the CPU, the sound chip is slightly different, but funny enough, you can actually mix and match them. So these aren't exactly standard sets. This is actually a US set with a world ROM that was in here. So I wonder if the sound is even going to work. But we only have one of the ROM 3F, which is this one here. So I'm just gonna swap the ROMs from the board here, the bootleg board. So this is the 3 sound ROMs. These are the CPU ROMs, 4E and 4D. They're here, and we can check here 4E and 4D. Come on, focus, and there you go, 4E and 4D. So I have the ROM in my tool. You actually put it this way. The number 1 is on top here, the first pin, and you select in the tool your chip. So this is a 27M27 press, yeah, select. It's gonna check the firmware, and then we're just gonna read. So this is read here, or you can click read here. Okay. what's on this chip? Not much. Wow. Is this blank? This isn't great. So I get confused actually with the IC reader. So the tool here tells you exactly where you should put your device. So it's at the bottom. Sorry. So the last pin here goes at the bottom. So we're gonna read it now. There you go. Yeah, there you go. So I don't quite know which one this is, but if we save it, we're gonna save it for Kung Fu Master, ROM, new folder, and this is 1, it says on the label, so we're just gonna save it as 1 because we don't quite know what it is. And then we're gonna go to a site called ROM Ident. ROM Ident, and we're gonna upload. So what this does, you can actually do this from ROM as well. So where is my ROM? It's in Arcade. Kung Fu Master, ROM. There you go. So you could actually check from MAME as well, but this is kind of fast. So this is ROM. Okay, this is 3A3E. So let me just check. Sorry, this is my Twitter. Don't want to see that. 3EA. So okay, so this is, anyway, what this tells me is that this goes on, in this case it goes on the A board and at location 3E. So this is the A board, and location 3E goes here. So this is the top one, so fair enough. So my camera just died. So I would, the dilemma here is I wasn't sure if 1 went here or here, but it actually goes here, which is fair to assume that 2 goes here and 3 will go here. So I can actually now use these knowing that the sound ROMs will work. So the next job now is to actually just change the Fujitsu chips. Actually, I can see that 1 was probably changed here already, but there's another one. These are 157, so 1, 2, 3, 4, 5, 6, 7. There's another one here, 8. I think that's it. And these are all 157. So I'm going to change all these, and then we're gonna try and boot the board and see what happens. Right, so I've removed all these, all the Fujitsu ICs and the 3 RAMs, just because I'm gonna reuse these, but I'm gonna socket them. So it's just thought while I'm socketing stuff, and it takes a while anyway, so I might as well just do the RAMs as well. So I've put a few back. I've one here. I have these here. Still have these 4 to do, and these 2 here. Should be 1 here. There you go. And the RAM, the other RAM. So let's keep going. So I've put the stack back together. I've socketed, I don't know how many, that many. Dodgy Fujitsu ICs, and you can actually test them. I'm just going to take a tester. Now, some of them were okay, but most of them were in fact just completely shot. Where's my tester? Here it is. She's going to show you. So if I take one of these, I don't remember which ones were good or bad, but most of them were actually pretty bad. There you go. So these are oh, this one was well, it recognizes it, but it might not be so it says it's 175, and don't want to put too much pressure on here. So 17, I bet you this one is going to be one of the okay ones. 17, okay, fault, there you go. So it recognized it as a 175, but it's telling me it's faulty. But in fact, I think I'll need 2 of them here in the lot, and I've thrown a few actually. These aren't all the ones I pulled out. I've also, while I was inspecting, I've also changed this op amp here, and I've taken one from this board over there. And this is the bootleg Kung Fu Master, because at this stage I'd rather have, again, like the Arkanoid one, a working one as opposed, or working original as opposed, sorry, a working original and a broken bootleg, as opposed to a working bootleg and a broken original. Let's see actually if I can show you everything I've replaced. I'm just going to pause this. There you go. I socketed these rams, put sockets and replaced all these 157. There was one here, not this one actually, that's not 157, although I did socket that. These here, and I socketed this ram as well. And then what I was inspecting, this is a prom. These are all the proms, and I saw that this one here, where is it? Do I still have it? No, there should have been a sticker on it. I probably threw it. Wow, I threw a few actually. But this one here was the 5P prom, and it was missing 2 legs. So I changed that as well. Man, there was so much wrong with this board, and that's even before I look at it, at even powering it. So I actually got the equivalent prom, because as you remember from the chart I showed you, all the proms matched, and the only ones that didn't match between that bootleg and this one was I know actually they were actually all the same. And on this one we've changed this, put a socket here, socketed those 2 rams, 3 sockets here, and one replaced this one here. And just for good measure, and I'm glad I did, I socketed this guy and this op amp, and I'm glad I did, because when I looked at the one that was here before, when I took it out, it was missing one leg. These I haven't checked yet. From experience, I mean, this one failed on the previous board, and I too replaced those 2 on the other board as well. So I wouldn't exclude that they might be dodgy, but we'll see. Now I haven't changed anything else, and on this board here I don't think I've done anything. I just replaced, there was a cap here that was just bad, and I think that's all. Oh, and I replaced a cap here that was broken. Or was it on the other board? I think it was on the other board actually. I just replaced this cap here on this G board, and it has a sub board which I suspect is to replace one of the custom ICs. So there you go. So I think we're gonna have to have a look at what it does. There you go, we're starting, and we're starting. There's no sound. Okay, that's interesting. So sound circuit is actually handled here. That should, yeah. So we're gonna have to probe and have a look at what the circuit is doing. So here we have the Yamaha chips, 2149. These are just sound. Are they square generator? I can't remember. I don't know that by heart. And here we've actually, it's a processor. It's what does it say? It's an 8603P. Okay, I'm gonna have to pull this out, but we're just gonna check actually. So I suspect actually this is on the right page here. Is it? Yeah, this is the sound circuit amplifier, and this is the sound circuitry here. So it'll be interesting to see. So I'm gonna have to do some probing. We'll probably start with the CPU really. That's where you want to check that, you know, things aren't floating, and actually, you know what, I need to pull the data sheet for this. Well, there you go. I didn't have to look very far. You can see some of these lines are just floating altogether, and some of them are just stuck high or low. Not much happening here in these lines. And looking at the schematics, these are these lines, and they sure enough they interface directly with the RAM. So they go straight here. They go through this. Is it another whatever multiplexer or whatever it is? But and they go into the RAM. So yeah, these lines are actually stuck, and these are as well. All this section here is floating. Sorry. So I'm gonna have a look at the bootleg board, see if it has that CPU as well, pull it out from there, and then replace it. And I'm pretty sure it'll be a good start. Yeah. It's not easy doing this with one hand. Not ideal. So I pulled this CPU out of the board here, so the 603, and I pulled actually the other Yamaha board. Essentially, I'm just gonna use this for part. There's no reason for me to have 3 Kung Fu Master original and a bootleg. And the architecture is very similar, except the top board, this one here, is actually on this section, and the bottom board is here, and we have sorry, the middle board is here, and we have the bottom board, which is a bit bigger here on this board, but things are a bit more compact here, so that's probably why. So yeah, while I was at it, I pulled out the Z80 and the Yamaha chips as well. That way, while I'm at it, it's done, and then I can use some of the other chips. Although I'm looking at it, there's a lot of Fujitsu chips here as well. I'm surprised they've lasted that long. Oh my god, it's riddled with it. There's probably 20 here, and I'd say there's another 20 on this one. There's probably more than 40 Fujitsu chips on this bootleg. This thing is a time bomb, essentially. Just a matter of time until it fails. But anyway, let's have a look. Oh, well, there you go. Well, there you go. So, yeah, well, there, perfect. So this was just a case. Wow, we're done already. Well, already. This was just a case of having this this bad chip here, this bad CPU that deals with all the sound circuits, the audio circuit. So it interfaces between the audio chips here and the ROMs and RAM. That's really good. Well, it's good to know. At least those guys are working then, and then the new op amp is working as well. So there you go. And this another Kung Fu Master rescued from the dead. And man, this was a handful, because I had to replace. So essentially, I had to replace all these and more. Yeah, that took a while. That actually took me the best part of the week. But it's worth it. There's another original IRM Kung Fu Master board working in the world. Anyway, I hope these help. I know they are not generating a lot of views, but I really don't care. It's more a case of documenting things and maybe having information for people who want to get into it. It's a bit daunting and overwhelming at first, but it's not overly complicated, and you know, all this stuff sort of starts making sense after a while, especially if you have to work on it. But I'd recommend working maybe on simpler boards at the beginning. Like these are my first 3-stack boards, and things get a bit scary when you start dealing with the multi-stack stuff. But you know, taking your time and looking on on the MAME information as well, and trying to find out where each ROM is, what they do, where the PROMs are, where the processor is, and what the other big chips are, what they do. There's a lot of stuff on the internet already. There's a lot more information, so it's making things much easier. Anyway, I'm rambling now. It's time to end this video. It's been going on for a while. Thank you for watching, and see you next time.